In this video, we're looking at solving simultaneous equations graphically. Now, solving simultaneous equations means we're going to solve a pair of equations with two unknowns, normally x and y. And graphically means that we're going to be using a graph to find the solution of these two equations. So let's start taking a look at some examples. Here we have two equations, x plus y equals 1 and y minus x equals 3. We're going to consider these in turn and we're going to draw the graphs of both of them. So first of all, we're going to get ourselves some graph paper with some axes on, and the first one we're going to look at is y minus x equals 3. Now remember, to draw a graph we want to have it in the form y equals mx plus c. So here we're going to get the minus x and we're going to add it on to the other side, so we have y by itself. So we have y equals, when we add x we get x on this side plus 3. Now the plus 3 is the c, that tells us the y-intercept. So that means it's going to go through this point here on the y-axis at 3, and the x is the m is the gradient or the slope of the line. In this case m is 1, so that means for every 1 we go to the right, we go 1 up. Just going to go through that point there. For every 1 across, it goes 1 up through that point there. And that's going to give us the line that goes through those points and then continues down the diagonal like that. On the next slide we're going to see that line drawn a bit neater. Now we're going to look at the second of the equations, which is x plus y equals 1. Again, we want it in the form y equals mx plus c. So this time we need to get the x away by subtracting it. So we're going to get y equals minus x, because when we subtract the x to get it to the other side we get minus x, plus 1. Once again, our c is plus 1, so this time it's going to go through that point there, and our m is minus 1. So this means it's going to be sloping the other way. For every 1 down it goes 1 to the right. For every 1 down it goes 1 to the right, which means it's going to go through that point and so on. So it's going to go down this way and up this way. And again, on the next slide we're going to see a slightly neater representation of this with a proper straight line. And there we have our two graphs, x plus y equals 1 in red and y minus x equals 3 in blue. Now there is a single solution to these simultaneous equations, and the solution is the point where the two lines meet. If we think about what a graph means, every point on the blue line is a solution to the equation y equals x minus 3, the blue equation. And every point on the red line is a solution to the red equation, x plus 1 equals y. So the simultaneous solution is the solution where both equations are true, and that is at the point where they cross, which is minus 1, 2. So the solution to the simultaneous equation is the point minus 1, 2, or we might want to write that as x equals minus 1, y equals 2. That is our solution to that pair of simultaneous equations. So now we're going to look at a second example, which is very similar. X plus y equals minus 2 and y equals 2x plus 1. Again, we're going to need a graph, so let's get up our axes. And we're going to plot both equations. This time we're going to start with the first one, x plus y equals minus 2. Again, to have it in the form y equals mx plus c, we're going to have to do a little bit of rearranging. And we're going to take away the x because we want it on the other side. So we get y equals minus x minus 2. The minus 2 is the c, means it goes through the y-axis at minus 2, which is down here. And m, in this case, is minus 1 again. So that means for every 1 down, it goes 1 to the right. For every 1 down, 1 to the right. So it's going to go through those points there. And if we join them up and continue the line, we get that line there. Again, on the next slide, we'll get a better representation of that line that is much straighter. And that's that first line. The second line, y equals 2x plus 1, is already in the form y equals mx plus c. So we don't need to do any rearranging. We see plus 1 is our value for c, so it's going to go through the y-axis at 1. And this time we have m is equal to 2. So that means for every 1 across, it's going to go 2 up. For every 1 to the right, it goes 2 up. So it's going to go through these points here. And then when we join those points up, we're going to get that line through there. Once again, we get a straight line version of this, all neatly done. And now we have the blue line x plus y equals minus 2, and the red line y equals 2x plus 1. So the solution of the simultaneous equations is where both equations are valid, and that is the point where the two lines cross, which in this case has coordinates minus 1, minus 1, that is x equals minus 1, y equals minus 1. And that's all we have to do to solve a simultaneous equation graphically. We draw the two lines and find the point of intersection, and the coordinates of that point are the solution to our simultaneous equations.